Today I want to do a review over section 8.4. So in this first example, it says a 24-meter pole is divided into two parts in a ratio 3:5. We want to find the length of the shorter part. Now, even though we're in a chapter dealing with ratios where we think automatically fractions, you have to also think back to we've done problems like this first semester. Because they're giving us the length of a pole, they're saying that it's 24 meters. Think about if I was to draw a picture. So from one end to the other end, that could be a length of 24 meters. But it's saying that that pole is being divided into two parts. It's just not being divided in half. It's being divided into the ratio 3:5, which means that when I split it up, the left side is 3, which I'm going to put an x with it. The right side is 5x. So it's 3x on the left and 5x on the right. So now, hopefully you notice that, hey, if I have two parts of an entire pole, I can add those two parts and set it equal to the entire length. So that's what I'm going to do in order to solve for x. I'm going to take 3x plus 5x and set that equal to 24. Notice that when I combine those like terms, it gets me 8x. That equals 24. I'm going to divide both sides by 8, and I get a length of x to be 3. But remember, we have to read the problem carefully. 3 is not my answer. I didn't ask for an x. I asked to find the length of the shorter part. So we've got two different pieces to the pole. Well, the shorter part is going to contain the smaller number. So that's the 3x. So 3 times 3 is going to get us that length. 3 times 3 is 9. We are talking units of meters, so I'm going to put that units with it. So 9 meters would be the length of the shorter part. In problem number 2, it says that James is standing 7 feet from a street light. James is 5 feet tall and his shadow is 8 feet long. How tall is the street light? So notice that I have a diagram here for you. The reason why the diagram shows that we have one triangle inside of the other is because I'm specifically telling you the distance that one object is standing from the other. James is standing 7 feet from the street light. So that's why we've got that smaller triangle inside of the bigger triangle. James is 5 feet tall, so notice that he's a part of the height of the small triangle, and his shadow is 8 feet. So that's the shorter side of the horizontal side. Now it's asking for how tall the streetlight is. I'm going to call that x. We just want to be consistent. Remember, I want to think about like height over shadow for one of the triangles, which means then I would have to think height over shadow for the other triangle as well. Okay, so if I start with the small triangle, the height would be 5 and the shadow length would be 8. So 5 over 8. Notice that in the big triangle, x is the height. I don't know what that is. But now this is where you have to be careful. 7 is not the length of the streetlight shadow. 7 is the distance between the streetlight and James. We have to think about the entire distance from the streetlight to the very end, which means we really need to add those two numbers together down at the bottom. So really 15 feet is that distance, which means that is the length of the shadow. So now that we have the proportion, I'm going to cross multiply. I'm going to multiply the 8 times the x, so 8x, because remember that's what happens here. And then I'm going to set that equal to then the product of 5 times 15. Well, 5 times 15 is 75. Now I'm going to divide by 8, and looks like we're getting 9.375. So not the prettiest number, but it does stop at a good number. So if you want to leave it as a decimal, you can. Okay, so now it's asking how tall is the streetlight? Well, the streetlight was representing x, so I'm going to throw on my units at the end, and it looks like we solved for our answer right away. 9.375 feet is the height of that streetlight. In this next example, it says Kate, who is 5.5 feet tall, stands 10 feet from a 16.5-foot lamppost. We want to find the shadow cast by the lamppost. So once again, notice that it's telling me exactly how far one object is standing from the other. So I'm not always going to give you a diagram. You're going to have to sketch it yourself. But notice that I actually want my diagram to look very similar to the problem that we just did above. I want a triangle inside of another one. So I'm going to let Kate be represented as the small triangle. Kate is 5.5 feet tall. So I want the 5.5 to be the vertical side of that small triangle. She's standing 10 feet from a 16.5-foot lamppost. Well, the lamppost is going to be the height of the big triangle. So right here, that vertical side is 16.5. And we know that the distance between these two objects is 10 feet. So 10 is going to be this. They want us to find the shadow cast by the lamppost. Now, technically, the shadow is this whole entire bottom piece. But I need information based off of triangles. And right now, that small triangle only has one side. So I'm actually going to call the shadow of the small triangle, so the shadow of basically Kate, I'm going to call that X, and I'm going to solve for X first. But then I need to recognize that X is not what my final answer is. I want the entire bottom of that big triangle. So just like before, I want to think about, something like height over shadow. So that's going to equal the height over the shadow. So I'm thinking about the two objects, and I want to be consistent when I'm setting up my proportion. So I'm going to start with Kate. So 5.5 feet would be the height, so that has to go on top. The shadow length is what we don't know. I'm going to call that X. I'm going to set that equal to the height of the lamppost, which is 16.5, over, but then remember, I need the entire bottom. I don't know what that is, but I know that two pieces of the bottom are here. That's 10, and that's X. So I need to add the 10 and the X together. I'm going to put it in parentheses, but now I'm going to do my cross multiplication. So that 5.5 has to get multiplied by everything that's in the parentheses, and the 16.5 is going to get multiplied by X. So we're going to have 5.5 getting multiplied by both 10 plus X, and that's going to equal 16.5 getting multiplied by X. I'm going to distribute that 5.5. So when I multiply that by 10, I get 55. 5.5 times X is 5.5X. Notice that I've got X's on both sides of my equation. So I'm going to subtract the 5.5X to get everything with the X over to the right. That would keep the 55. 16.5 minus 5.5 is going to give me 11, and that's still with X. I'm going to divide both sides by 11, and we find out that X is 5. But remember, X is representing the length of Kate's shadow. I want the shadow cast by the lamp pole. So that means I need to add the 10 and the 5 together. So it looks like 15 feet would be the length of that entire shadow. So make sure you know exactly what X is representing. Okay, here's our last problem. The height of a flagpole is 10 feet. Sally, who is 5 feet tall, casts a shadow of 3 feet. Find the shadow of the flagpole. Notice that when I was reading through this problem, I don't know the distance between Sally and the flagpole. So when I don't know the distance between the two objects, that indicates that I want to draw two separate triangles when I'm putting together this problem. Okay, so, oops. Come on, pen. There we go. All right, so one of these triangles is going to represent the flagpole. So it says the height of the flagpole is 10 feet. So height, I want the vertical side. The other triangle is representing Sally. Sally is 5 feet tall, so she's going to be the vertical side right there. Sally casts a 3-foot shadow, so 3 has to go on the bottom of that second triangle. We want to find the shadow of the flagpole, so X goes on the bottom of the first triangle. And then once again, we can think height over shadow, so 10 over X, and that's going to equal height over shadow, so 5 over 3. I want to cross multiply so I can start solving for x. But notice that once I solve for x represents the shadow of the flagpole, and that's what I want. So I don't have to do anything other than solve for x. So we'll have 5 times x, and that's going to equal 10 times 3, which is 30. I'll divide both sides by 5. I'll get x to be 6. 6 is my answer. I'm not going to forget my units, so it's actually 6 feet.